If the equation is not in slope-intercept form, convert it by solving for y, identify the slope and y-intercept of each line, and graph both of them, then determine whether they are parallel or intersecting and explain why. Line A is written y equals negative 4/3 x minus 8. Because the y is completely by itself, this is in slope-intercept form, so I don't need to change it. Line B, however, the y is with a lot of other things on that side of the equation. So looking at this equation, negative 4x minus 3y equals 6. Sometimes visually it helps me to draw a line down the equal sign so I know for sure what is the left side and the right side. First of all, I want to get y by itself. I have a 4x on this side, a negative 4x that needs to be moved to the other side. So to move it, we use inverse operations. We're going to add 4x on both sides. Be sure that you write down, that you follow your steps. Negative 3y, so don't lose that negative, equals 6 plus 4x. Then we'll divide both sides by negative 3, because negative 3, when it's next to the y, it's being multiplied. So the inverse operation is division. Y equals negative 2. We have positive 4x over negative 3. So positive over a negative, that will be a negative. 4 over 3 cannot reduce, but if you can reduce your slope, you always should. And the x, we'll write it right next to the slope. Now I like to have the x part be in front, so I'm going to rearrange this to be y equals, this is a negative 4/3 x, and this is a negative 2, so minus 2. My slope for this line is negative 4/3, and my y-intercept is negative 2. The slope for this line is negative 4/3, and the y-intercept is negative 8. I'm going to graph these. Negative 8 is my y-intercept, and then negative 4 over 3. So we would go down 4 into the right 3. But as you can see, that would be somewhere over here. So really, I'm going to go up 4 and to the left 3. 1, 2, 3, 4. 1, 2, 3. Which, as you can see, would still give me a negative slope. Always connect those dots with lines and arrows at the ends. Your y-intercept for the blue line, line B, was negative 2, and it had the same slope. We go down 4 and to the right 3, or you can go up 4 and to the left 3. And these lines are parallel. And how do we know that? Even before we graphed, we can see this slope is the same as this slope. They have the same slope. Parallel lines have the same slope. Let's try another one. All right, is it in slope-intercept form? Yes, y is by itself. So let's decide, what are my slope and y-intercept? The slope is the number that is in front of that x, so 2. I like my slope to be a fraction, so I'm going to write it as 2 over 1. The y-intercept is the number that comes after the x, or does not have an x attached to it, and that would be a positive 5. Now it's time for us to convert line B. We need this to be in slope-intercept form. I'm going to draw a line to show me the left side of the equal sign and the right side. And what's on the same side as the y, but furthest away from it, is x. So that's what I'll start with, inverse operations. This is a positive x because there's no sign in front. So to move it, I use the inverse operation of subtracting an x. This would be x minus x plus 2y, so this is a positive 2y, 8 minus x. 2 is being multiplied by y, so we'll use the inverse operation of multiplication, which is division. Divide this side by 2, divide this side by 2. When you divide an entire side by 2, you can separate it and write it as this over 2 and that over 2 when it comes to division. All right, this is a y. 1y is equal to 8 divided by 2 is 4. And this one right here can be a little tricky. We have negative x over 2. Remind yourself that the number that's in front of that x is a 1. If there's not another number, it's a 1. I have a negative 1x in the numerator and a 2 in the denominator. I like to write the slope as a fraction times x. So this will become negative 1 over 2 times x. All right, negative 1 over 2 times x. If we were to write that with the x part first, the negative 1/2 x would go in the front, and 4 would stay positive over here. So my slope would be negative 1/2, and my y-intercept is 4. Y-intercept of 5, and then the slope is 2, so I'm going to go up 2 over 1, and then continue. The y-intercept of line B is 4, and our slope is negative 1 over 2, so I'll go down 1 over 2, and I'll also go in the other direction, so up 1 to the left 2. Now these lines are clearly not parallel because they cross. So they are intersecting. But they're not just any type of intersecting. This is a very specific type of intersection. These lines cross at a 90-degree angle. Their intersection makes 4 right angles. Therefore, these lines are called perpendicular. They intersect at a right angle. And you know how parallel slopes had a special relationship? Well, perpendicular slopes also have a special relationship. Perpendicular lines intersect at a right angle, 90 degrees. They make a 90-degree angle. Slopes of perpendicular lines have a special form. Take a look at the slopes from example 2. We have 2 over 1 and negative 1 over 2. 2 over 1 somehow became negative 1 over 2. How does that happen? Well, they decided to change the sign, so it went from being positive to negative, and they flipped the fraction. So it went from 2 over 1 to 1 over 2. Okay. Change the sign and flip it. There's actually a math label for that. The perpendicular lines have opposite, meaning change the sign, reciprocal, meaning flip it, slopes, and that's all talking about the slope. Perpendicular lines have opposite reciprocal slopes. Parallel lines have the same slope. So if the given slope is 2, what is the parallel slope? It is also 2. What is the perpendicular slope? Okay, so we'd have to change the sign. So instead of positive, it will be negative. Instead of 2 over 1, if you want to see this as a fraction, it would be 1 over 2. All right, negative 1 over 3. What's the parallel slope? The same. What's the perpendicular slope? It's the opposite reciprocal. Therefore, we need to change the sign and flip the fraction. It's negative, so change it to positive. It's 1 over 3, so change it to 3 over 1. You could also write that as 3. Negative 2 over 5. What's the parallel slope? It's negative 2 over 5. Parallel lines have the same slope. And then a perpendicular slope is the opposite reciprocal. Change the sign from negative to positive, flip the fraction, 5 over 2. The given slope is 1. What is the parallel slope? Parallel slope is always the same. But what is the perpendicular slope? It's the opposite reciprocal. We need to change the sign and flip the fraction. Ooh, that's not a fraction, but I can write it as 1. 1 over 1. So instead of being a positive 1 over 1, now my perpendicular slope will change the sign so it should be negative and flip the fraction 1 over 1. That's also just negative 1. The given slope is 2/3. What is the parallel slope? It's the same. Parallel lines have the same slope. The perpendicular slope is the opposite reciprocal. We need to change the sign. It's positive here, so make it negative. And reciprocal, we need to flip the fraction. 3/2. The given slope is 0. What is the parallel slope? It's the same. Always the same. Perpendicular slope, though, you've got to change the sign. 0 is neither positive nor negative. And then flip it. So if I were to write 0 as a fraction, that could be written just like the others, 0 over 1. And then if I were to flip that, that would be 1 over 0. Uh-oh, you can't have a 0 on the bottom. You can't divide by 0. So what kind of slope would that be? That would be an undefined slope. Which means that if your line had an undefined slope, that would mean a vertical line, and you wanted a line parallel to that, then that slope would also be undefined, and your perpendicular slope would be the reciprocal of undefined. Well, undefined happens when we're dividing by 0, so the reciprocal of that would be something like 0 over 1. That's just going to be 0. Right? Because an undefined slope is a vertical line and a 0 slope is a horizontal line. So for these examples, we're going to first make a prediction. Do we think they're parallel or perpendicular? Or intersecting? Well, these look parallel to me. They're not crossing. I don't know if they'll ever cross. That's my prediction. All right, and now we need to find the equations so we can verify if our prediction is correct. Okay, so first I need to find any places on the grid where the line crosses at a grid crossing, if that makes sense. So any points on the graph. This point is in between. I want it to be at a grid crossing right there. There's one. Can you find another one? All right, there's one. I think there's one too. Okay, so I'm going to draw a slope triangle between these 2 points, and the base of that will be delta x, so that's 5 units, and the height will be delta y, that is 2 units. As we look at this line going from left to right, it is steadily increasing. So our slope should be positive. Positive delta y over delta x. 2 over 5. Crosses the y-axis at 5, so that will be my y-intercept. So the equation of this line would be y equals mx plus b, y equals slope times x plus y-intercept. Let's look at the burgundy line. Find some points. I see the y-intercept is -4. I'm going to write that down here right now. And, oh, here's another point. Does that pattern continue? Okay, so I did get the correct point. Delta x is 2 units, delta y is 1 unit, and as we look at this line from left to right, it is increasing, so my slope is positive delta y over delta x, so 1 over 2. The equation of the line y equals mx plus b should be y equals 1/2 x plus -4. Oh, well, we don't need to have plus a negative, so you could write this as -4. Okay, so now we need to actually look at the slopes to see if our prediction was correct. Parallel lines have the same slope. perpendicular lines have opposite reciprocal slopes. We predicted that these were parallel. So, do these lines have the same slope? One of them is 2/5, the other is 1/2. They are not the same slope. So, my prediction was wrong. It was incorrect. Line A and line B are intersecting, not where we can see it, but they will eventually intersect because they do not share the same slope. Let's try part B. We're going to make another prediction. I think these are parallel. I think that they will have the same slope. Let's test it out. Okay, so I'm going to find some points. I see one right here. The y-intercept is 5. So the first line, I will say the y-intercept is 5. And I need to find another point. This one looks good. I'll draw my slope triangle. Delta y is the change in height, so that would be 3. Delta x is the change in width, and that would be 4. And as we look at this line from left to right, we see that it is decreasing, which means the slope will be negative. So delta y over delta x, we have 3/4, but we know our slope is negative because our line is decreasing. So our equation would be y equals negative 3/4 x plus 5. The green line, I can see a y-intercept at -7. And then I see another point here. Let's look at that. Delta y is 3. Delta x is 4. And as we look at the lines left to right, this green line is also decreasing. So the slope will be negative 3/4. And that gives me an equation of negative 3/4 x plus a -7, so minus 7. Okay, so were we correct? Are these parallel lines? Yes, they have the same slope. Our prediction was correct. Let's try some more. Ooh, these don't just intersect. These look like they might have a special type of intersection known as being perpendicular, making a right angle. That's going to be my guess. Let's find some points. The y-intercept of this one looks to be like it's +5. And I need to find another point. I believe this is another point. Delta y is 5 and delta x is 1. And as we look left to right, this line is very steeply increasing. So delta y over delta x would be 5/1, and because it's increasing, that's a positive slope. Y equals mx plus b. Oh, our slope and y-intercept happen to be the same here. Let's try this one. It looks like our y-intercept is at 0, 0, and I think I can find another point here. To test if that truly is the triangle, let's look over here and see if, okay, there is another point. Yep. This delta y is 1, delta x is 4. This line is decreasing as we look left to right. Delta y is 1, delta x is 4, and it's decreasing, so -1/4. The y-intercept, as we found before, was 0, so y equals slope times x plus b plus 0. Adding 0 doesn't change it, so you don't need to actually write that plus 0. Okay, we predicted that these lines would be perpendicular, which means their slopes would be opposite reciprocals. So let's test if that is the case. Our slopes here are 5 and -1/4. Now, if I take 5 and I make it negative and I flip it, that's -1/5. That's not -1/4. So they looked really close, but yeah. Our prediction is incorrect. They are simply intersecting. The slopes are not opposite reciprocal. The slopes are different, like these lines are not parallel, but they're not opposite reciprocal slopes, okay? And that's what we need to have perpendicular lines. Okay, let's try this one. What do you think? Maybe these are going to be perpendicular. We're looking for opposite reciprocal slopes. This has a y-intercept at 2. And I don't see another, oh, here's another point. I like to find another one just to make sure these, if you draw two slope triangles, make sure that they look like they are the same size. Otherwise, you're not finding the points correctly. So delta y is 3, delta x is 4. And as we look at this line from left to right, it is increasing, so our slope should be positive 3 over 4. Y equals 3 over 4x plus 2. Before we find the points on the orange line, what should the slope of line B be in order for these lines to truly be perpendicular? What would this slope be? Hopefully you said negative 4 over 3. But let's check it out. I have the y-intercept is negative 5. Here's another point, and there's another point. Delta x is 3, delta y is 4, and as we look at this line from left to right, it is decreasing, so the slope should be negative 4 over 3. Y equals negative 4 over 3x minus 5 plus a negative 5. Are these opposite reciprocal slopes? 3 over 4, is that the opposite reciprocal of negative 4 over 3? Yes, it is. They changed the sign from positive to negative and flipped the fraction. So our prediction was correct. The lines are perpendicular because they have opposite reciprocal slopes. To review, parallel lines have the same slope, and perpendicular lines have opposite reciprocal